Okay, so we can have an exponential model that looks something like this, right? This is an exponential model. And the problem is when we were doing our exponential growth models and decay models, they were based on base E. So what we'd like to do is be able to have it always be a base E. And it turns out we can do that. So it has to do with property number 4 for logarithms. So if you remember, property 4 says if you have a base and then you have an exponent log base B, same base, equals x, that just equals x. Okay, so now what we're going to do is we're going to think of it like this. We're going to think e to the natural log of some base, some number is going to equal b. Okay, so this is from property 4. It's the same thing. Your base here is matching the base of the logarithm in the exponent, and so it just equals b. Okay, so this next part seems a little backwards maybe, but what we're going to do is we're going to replace the b in our equation. We're going to replace it with this. So this means our model is going to look like y equals a, some constant, and then I'm going to have e to the natural log of b times that exponent. So I'll be multiplying times the exponent there, like power to a power, right? So you multiply those. Okay, so that's the model right there. And now it has a base like our exponential growth and decay models in terms of a base e. This natural log of b, remember b is a constant. You can figure out what that is. A calculator will tell you the natural log of a number. Okay, so that we can figure out. And that's what we'll show you in this next example. So the function models world population, g of x. So now we're doing world population in billions, x years after 1949. Rewrite the model in terms of base e. So here's the function that they give us, but we don't want this 1.016. That's like the b from our model above. Like if you scroll up, you can see that. So we're going to replace. We'll keep the 2.634, but we're going to replace that 1.016 with e to the natural log of 1.016 times x, okay? And so that's all true and good. But usually they want us to get a decimal approximation for that constant. So what is the natural log of 1.016? So you go to your calculator, you turn it on, and you go natural log 1.016. And I get it's about 0.0159. Yeah, if I round it off, it's 1587. So if I were to do 3 decimal places, it would look like that. The book only does 2 decimal places, but I kind of like doing the 3 because then it looks kind of goofy because of the numbers. But anyway, now you have 2.634e. You have what that natural log is, about 0.0159 times x. And now you have a new model for the function in terms of having a base e. Okay? And that's what it does.